Hi, this is Phil Szymanski, and I'm giving my final presentation on how to give a class period on presenting the random forest algorithm. So starting with the learning objectives, what they need to know by the end of this class period is why random forests are used and a little bit about what they are. So basic aspect of decision trees, how to create them using random aspects and random forests. And then also at the end, how to implement a very basic version of that. So they'd want a little background on decision trees. They'd have to at least know what a decision tree is before they could do random trees and random forests. So we'd run through this case, which is what I went over last time I presented on random forests. And it was the example of a person, their decision tree, trying to figure out if they should play tennis or not on a certain day. So it's split on three predictors: outlook, sunny, overcast, or rainy, wind, whether it's strong or weak, and the humidity, whether it's high or normal. So I'd go through the way of splitting a decision tree, and I've learned that there are multiple ways of doing this, but the one that I would go through and how to split out the tree for random forests and how I'm going to teach to implement them is splitting the predictors on purity. So starting with the outlook predictor, we'd go sunny, overcast, and rain, and we'd stop at overcast because that branch, that leaf of the tree, is a pure node because every time it's overcast, the person plays tennis. So then we go off into sunny, rain, and do the same thing on humidity and wind. So going over what a random forest is after they have a little bit of background on what a decision tree is a random forest is a collection of decision trees, and that forest is randomized in two ways. The first way is that the training rows used to train the trees themselves are randomly selected from the data set. And the second way that the forest is random is when those trees are being trained, the predictors that are being split on are randomly chosen as well within each tree as it's being trained. In order to predict a new value, so this is just telling them, so after you've trained your forest, how do you use the forest? So in order to predict a new value, you'd feed each tree in the forest the input variables, so the predictors. And you would take the mean of the results from the forest if you are using regression decision trees, or you would just take the mode of the classification trees if you're using classification trees. So whatever class is selected the most in the forest using that input vector. Why use random forests? One reason is that the actual concepts and the implementation is pretty simple, and in that it's pretty elegant because it's a very robust algorithm. One tree is stupid and prone to mistakes, so it's very easy to use one decision tree and get to the wrong result, but averaging many decision trees in a forest often can alleviate that reliability on that one tree to make a mistake. Random forests are proven to draw accurate conclusions from even partial data sets, so they can very easily see a connection there that may be pretty tenuous in the training data just by looking at it. But one downside of that is because it actually draws very strong connections using not that much data, it actually may overfit the data by seeing a connection that actually it shouldn't be assumed as a connection. So an example of how to implement it just conceptually, and just going back to the tennis example because that's an easy one. Every day John decides if he wants to play tennis based on three criteria, and then I did these predictors differently than in the example of explaining a decision tree. But John is trying to decide whether he wants to play tennis, and he's going to use three predictors, whether it's windy, yes or no, whether it's rainy, yes or no, and whether it's cloudy, yes or no. So the first step would be to train the forest. So using a historical set of data, maybe the last 50 or 100 days that John played tennis, and looking at the weather conditions, whether it was windy, whether it was rainy, whether it was cloudy, you could build a matrix. It would be a binary matrix, zeros and ones. 0 or a 1 for whether it's windy, a 0 or 1 for whether it's rainy, 0 or 1 for whether it's cloudy, and a 0 or 1 for whether John played tennis or not. So that would be one training row in the data set. So randomly selecting 2/3 of that data set, you could train a tree. Then you could train that decision tree using your 2/3 of randomly selected data set with replacement, splitting on the predictors that are also randomly selected. So there's our two versions of randomness that are in these random trees. Selecting the data set at random, and then also selecting the predictors that you're going to be split on as random. And then keep repeating that until your forest is the size of that you predetermined. So maybe you might do like 25 trees or 100 trees in your forest. So that process would have to be repeated over and over until you have a forest. Then once you have your forest, you could predict whether John is going to play tennis based on weather conditions. So you would take the first three binary values, windy, rainy, and cloudy, and feed each tree in your forest that data set, just those three binary values, whether it's windy, rainy, or cloudy, and then the tree will take you through whether John is going to play or not, according to that tree. And then in the prediction, I said you take the mode of your results for a classification tree. So that's what we have here. It's a class. It's a binary classification. 1 being John playing, 0 being John doesn't play. So you would take the mode of the results in this case, not the average, because we haven't done a regression example. In the class, in order to drive that concept home, I drew up a little class activity. So what I would have to do in order to plan for this activity is create a bag with little pieces of paper in it for each group. So I'm going to have the class assemble into groups of 4. So each group would have its own bag with a bunch of little slips of paper in it, and each slip of paper in that bag would represent a training row. So once again, just 4 binary values, whether it's windy, whether it's rainy, whether it's cloudy, and whether John played or not. Then one person in that group, each group, would have to be the program, sort of like main thread, so running the program. And the other 3 people in that group each represent a tree in this random forest that exists within the program. So the first step would be each tree would randomly choose 6 training examples. So there would be 10 in the bag. So each tree is going to choose 6. One by one, they're going to go and choose with replacement. And they're going to have probably a little cheat sheet on how to train a decision tree. And they're just going to go through their 6 training examples, probably write down on a piece of paper what their tree is. And then after each tree has been trained, so 3 people in that group now are a decision tree, and they have each on their piece of paper a decision tree. And the main program thread will then, person in the group will then choose 4 new training examples from the bag and basically pull each other member of the group, saying, okay, like here's the data set. Are you going to play tennis or not? And then take the mode of the results and see if that forest of 3 people were right. So then we just circle back and make sure we all understand why random forests are used. They're simple and robust. As long as you're taking into the account that they may overfit. Sort of understand what are the basic aspects of random trees and forests, and also understand a little bit about how to implement them. Then just going over the programming assignment really quickly before we set them loose to go do that. First, I'd call out that in the programming assignment, can't use octave, because the function that I would have them use and the function that I used when I built out the example was this fitCtree function, and it only exists in the MATLAB library. So there is an empty version of it in the Octave library, but nobody has provided an implementation for that yet. So they'd have to go in and use MATLAB for this. And in order to use that fitCtree function, there isn't a way yet to have it train the tree randomly. So in this program assignment, just wanted to call out that this isn't going to be a true random forest. It is going to be random in that we're going to randomize the training data set, but we're not going to randomly select the predictors that we're going to split the decision trees on. and then I just give them a location where they can find the files for the program assignment, which I will walk through quickly. So once again, I'm showing this in Octave, but this isn't runnable in Octave. But if you just pull these into MATLAB, it will be able to run this function. But if you try to run this in MATLAB, it's not going to let you in Octave, it's not going to let you because it doesn't have the fit C tree function. So walking through the source code, my solution source code is what we're looking at. The first part just loads the data set, so that's pretty simple. And the data is exactly as I was describing it in the lesson plan. Basically, the first, there's 4 columns, and the first 3 columns represent whether it's rainy, cloudy, or windy. And then the 4th column represents a binary indicator for whether or not John played tennis that day. So after that gets loaded, you want to tell it what the size of our forest is. So I chose 100 trees. In training, we start with, we're going to train over 1 to the 4th size. So each iteration through this loop is going to create 1 decision tree. I picked a bag index matrix, and it randomly selects 2/3 of, it randomly selects 67 numbers from 1 to 100 in this, or 1 to the size of the training data set. So 2/3, basically this comes up with an index of 2/3 of the values from the training set that we're going to use. Then this actually builds the matrix, so the actual input values from those indexes that were randomly selected. So basically, in my sample data, there's 50 rows. So it picks 33 of those rows, the indices of those rows, and then this line goes and finds those rows and builds an input matrix from those. And then, this actually just instantiates the variable. This actually creates the training matrix. And then using that matrix and this fit C tree function, this will create the first tree in the forest. So I actually had to use these squiggly braces so that a new, I think it's called cell structure, is created each iteration through this loop. And using the fit C tree function, this is the input part of the tree that's going to get trained. So this is just columns 1 through 3. This is the output part, column 4 of the training matrix. And then in the part where you set parameters, I tell it to prune based on impurity, because by default it prunes based on error and standard error and information gain, which is not, those are more complex concepts than what I taught in the lesson. Then it stops and it actually shows, so actually it's going to do that 100 times because you build 100 trees in the forest. After it does that, it stops and it just displays the first tree in the forest. So that part's pretty cool. The part to note is when it splits that tree out, each variable that it shows in the tree, each branch, it'll show like x2 is less than 0.5 or greater than 0.5. Basically, with binary indicators, that just means is it 0 or 1. So for each branch in the tree. Then so once we have our forest built, I do a similar thing, randomly getting 1/3 of the test, 1/3 of the indices from the data set to test with. And then it goes through, so it gets like 16 values because 1/3 of 50 is 16. And then it goes through and uses the whole forest, so 100 times. So for each value of the test set, this iterates through, and then for each value of the test set, it goes through the forest 100 times because there's 100 trees in the forest. And then it takes the mode of what it finds there. So this is just a matrix building. What is the result of what the whole forest told me was going to happen? And then this takes the mode of that. So, okay, what happened the most, zeros or ones? Did John play or not? And then it goes and finds the actual value in the training set, what John did, play it or not. And then I build another matrix called performance, and it just compares what was predicted and what is actual. And then I get a percentage. So basically this matrix will tell me how often I was right, and then this just builds a percentage off of how often I was right. So I take the sum of all the times I was right and divide it by the times I could have been right. And then I just print that out. So, and we're running on over 15 minutes here, so just show that, this is what I would provide the students. So I basically took out the part where it was trained, and I told them, train it using 2/3 of the training set. Use the fit C-tree function and prune based on impurity, because that was a difficult part. And then also show them how to use this sort of notation. And then also I took out the prediction part of the code. So I went in here and just told them, validate your forest, put predictions in a matrix named pred, and put the actual values in a matrix named actual. And then I still have the same code at the bottom that compares those two matrices and gives a percentage of performance. Thanks for listening.